tail from the sun's radiation blasting it, but it also has a forward-facing tail.
If the sun is here and the comet is here, the sun sends the solar wind to the comet, the tail goes behind the comet. Guess what? This comet is at the reverse side.
But is it nature or something else? We're gonna find out.
An extraordinary wanderer from the depths of space is drifting past our solar system. Meet 3I Atlas. Its tail is evolving. Its journey spans billions of years, and its origin lies beyond our sun's reach. In this video, we'll explore what NASA's latest observations reveal, uncover how scientists decoded its strange behavior, and explain why this fleeting visitor could dramatically expand what we know about the universe. You'll discover its ancient origins, the ongoing debate around its nature, and the new clues hidden in its changing tail. When astronomers detected 3I Atlas on July 1st, 2025, using the Atlas Survey telescope in Chile, they instantly realized this wasn't a typical comet. Its path through space wasn't circular or elliptical. It was hyperbolic, which means it isn't bound to our sun and came from far beyond our solar system. That alone makes it extraordinarily rare. Only the third confirmed interstellar object ever recorded after Oumuamua and 2I Borisov. Its velocity stunned scientists, roughly 60 kilometers per second, or about 130,000 miles per hour. That's fast enough to escape the sun's gravitational pull forever. Combined with its highly eccentric trajectory, this speed confirmed its origin from another star system. Based on chemical modeling and computer simulations, researchers estimate that 3I Atlas may have formed between 7 and 10 billion years ago, long before our sun came into existence. Images taken by NASA's Hubble Space Telescope revealed a glowing coma of gas and dust surrounding a solid icy core estimated to be around 3 to 5 miles wide. It's a teardrop-shaped cloud, illuminated by sunlight as 3I Atlas continues its billion-year journey through the galaxy. The data also showed familiar signatures like carbon compounds and water ice, suggesting that the ingredients for planets and life may be far more universal than once believed. To capture this unprecedented event, observatories worldwide joined forces. Space telescopes, Mars orbiters, and even missions headed toward Jupiter and beyond have been tasked to photograph or analyze this comet from different angles. Each image and spectrum helps scientists compare its material to the comets in our own solar system. The result? 3I Atlas has become a cosmic time capsule, a frozen relic that predates our world by billions of years. By studying it, scientists hope to understand how early star systems formed and what materials shaped their planets. This isn't just another icy rock passing by. It's a message from the universe's ancient past, written in dust and light, crossing our neighborhood for the briefest moment in human history. Whenever a mysterious object like 3I Atlas appears, curiosity sparks across the globe. Could something so strange, moving so fast, really be natural? Some researchers, such as Harvard physicist AviLoeb, argue that we shouldn't immediately dismiss unusual possibilities. He points to details like the object's speed, brightness variations, and spectral hints of metallic elements, factors worth investigating, not ignoring. But the mainstream scientific view remains clear. 3I Atlas behaves like a natural comet, not an engineered object. Spectroscopic studies have detected typical compounds: water vapor, carbon dioxide, and carbon-rich dust, all consistent with natural outgassing processes. When sunlight warms the comet's icy surface, gas jets erupt, releasing dust and forming the tail we see. That's normal comet behavior, even for one from another star system. Physicist BrianCox offered a refreshing perspective by calling 3I Atlas a time capsule, not a spacecraft. He explained that the comet's significance lies in what it carries: ancient, unaltered matter from before our sun existed. Its age and chemistry make it a sample of another planetary nursery, giving scientists a rare opportunity to compare star systems. Still, this debate serves an important role in science. Asking bold questions, even unlikely ones, drives deeper investigation. If something appears unusual, scientists test, measure, and refine their theories until the evidence points in one direction. In the case of 3I Atlas, every bit of credible data so far supports a natural explanation. Its tail, composition, and orbit all match what we expect from a comet ejected during the early chaos of a distant star system. Yet, there's poetic beauty in the speculation. It reminds us that exploration is about curiosity, about daring to ask what else might be out there. 3I Atlas shows how one tiny visitor can reignite humanity's sense of wonder, bridging imagination with hard data. Whether it's a cosmic relic or something entirely new, this object challenges us to look at the sky not with fear, but with fascination. And as we'll see next, the latest NASA images of its tail may hold even deeper clues about its true nature. Just before 3I Atlas moved behind the sun, NASA's observatories and partner telescopes captured a series of high-resolution images that left scientists astonished. The comet's tail, the glowing stream of dust and gas trailing behind it, wasn't stable. It was shifting shape, brightening, and even twisting. For a few days, the tail structure changed so dramatically that it looked like an entirely different object from one observation to the next. Why does that matter? Because a comet's tail is like its heartbeat. It reveals what's happening beneath the surface. As 3I Atlas nears the sun, solar radiation heats its outer layers, causing frozen gases to vaporize and burst outward in jets. These jets push dust into space, forming the signature tail. But in this case, the intensity and direction of the jets seem to fluctuate rapidly, suggesting an irregular or unstable nucleus. Some images showed multiple jets firing simultaneously, producing streams of gas that intertwined and curved under solar wind pressure. Others revealed faint green hues, the result of diatomic carbon molecules fluorescing in sunlight. This coloration, combined with its fast-evolving shape, points to a complex mixture of ices and organic compounds being released in bursts. Even more intriguing, data from planetary spacecraft indicate that 3I Atlas's tail expansion rate is unusually high for a comet at its distance from the sun. That means it might contain materials that react more strongly to heat, possibly due to its long exposure to cosmic radiation during billions of years in interstellar space. In simpler terms, it's behaving like an ancient traveler encountering sunlight for the first time in eons. Unfortunately, the comet's path takes it directly behind the sun from Earth's perspective, temporarily hiding it from our telescopes. But spacecraft around Mars, and even those heading toward Jupiter, will continue monitoring it. Once 3I Atlas emerges again, scientists expect to see whether the tail continues evolving or begins to dissipate. These observations are more than just pretty pictures. They're a key to understanding the physics and chemistry of interstellar materials. The changing tail of 3I Atlas is not a sign of mystery or technology, but a natural masterpiece, a dynamic, glowing trail that captures the raw beauty of cosmic evolution unfolding before our eyes. 3I Atlas isn't just another comet. It's a messenger from a time before our sun even existed. Its changing tail, its interstellar chemistry, and its billion-year journey remind us that the universe is still full of surprises waiting to be uncovered. Every image, every light reading, and every chemical clue from this traveler adds another piece to the story of how stars and planets form across the galaxy. When 3I Atlas reappears from behind the sun, scientists hope to unlock even more secrets hidden in its dust and ice. Until then, it stands as a symbol of how far human curiosity has taken us, and how much more there is to explore. If you enjoyed this video, don't forget to like, share, and subscribe. Thank you for watching. Your support keeps our journey through the cosmos alive.